3.4 notes. Piecewise functions. It's a function that's written using two or more expressions or pieces. Notice what it says in this box. Graph the functions individually and cut the piece off the x values behind the word if. So, don't draw this yet. I'm going to look at this as y equals x minus 1, which is a traditional mx plus b. My y-intercept is -1, and my slope is up 1, right 1. It's a positive slope going up and right, or down and left. So I have a line that looks like this, if we're actually straight. And that's y equals x minus 1. I also have the line y equals -2. Remember, y equals a number is a horizontal line. Y is always -2. And so I do that. But piecewise is different. I need to cut off anything that doesn't fit this stipulation. So I want to graph this slant line if and only if x is less than or equal to 3. Well, 3 is right here. So that's my line that I'm going to use to cut. I'm going to cut along that dotted line. And I'm going to put a solid dot because it says greater than or equal, less than or equal to 3. So this is where I'm going to cut. Now I want less than -3, so I want this part of my line. I don't want this part. So I just cut it off. And that's it. Now, the second part, the horizontal line. I want it if it's greater than 3 only. So again, I come down here, but this time I'm going to put an open dot because I want it greater than, but not greater than or equal to 3. So I'm going to cut it right there. And that is my piecewise graph. Okay? And that's one way to do it. The other way to do it, now you can go ahead and copy that down now. The other way to do it is to use a table. And like I said, we can use the calculator now. So we're going to put in y equals x minus 1. X minus 1. And I'm going to use a table. So I go to second graph and get my table. But remember, I want numbers less than 3. So I don't want 0, 1, or 2. I want less than or equal to 3. So now I can just write down those numbers. X minus 1, and I put down 3, 4, 5, 6, 7, 8, and so forth. And then I just copy from the table, and this was 2, 3, 4, 5, 6, 7. And I look at, here's 3, 2. And here's, wait a minute, sorry, I want less than or equal. If I only had a brain. So I want less than or equal. So my first one is going to be, my bottom one is going to be 3. And then I'm going to go up. So it's going to be 3, 2, 1, 0, -1, -2. And I just copy off the table here. 2, 1, 0, -1, -2, -3. And then I would just graph those. So if I didn't want to do like I did the first time where I graph and cut using an eraser, I could use the table here and just go backwards. So if you notice, I have 0, -1. That's right here. 1, 0. That's right here. 2, 1. 3, 2. Well, actually, should I? I'm off a little bit on my drawing. 3, 2. There's my solid dot. And down to -2, -3. And so forth. You can just use the chart. Then I'm going to do the other one. Y equals -2. Well, this is always going to be -2. You don't really need the table for this. But I could. And then x has got to be greater than 3. So I can't put 3 in here. So I'm going to put 4, 5, 6, 7, 8, 9. But I could remind myself 3 and like an open circle. To remind myself that I'm starting there, but I'm not including it. So you can do this either way you want. (2x minus 3), okay, I'm going to show you real quickly, 2x minus 3, that is a y-intercept here with a slope of up to right 1, and so forth. But I want numbers less than or equal to -1, so I don't even want to go this way. So I'm going to go down to left 1, and that's actually where I'm starting, right there. My new starting point is right here. And then I'm going to go down to left 1, down to left 1, and so forth. And it says less than or equal, so I'm going to use a solid dot and just go that way. Now once again, I'm using my calculator. 2x minus 3. And I go to the table. I want to use numbers less than negative or equal to -1. So -1, -5. That's my first dot I have there. Then -2, -7. That's my second dot. -3, -9. There's my third dot. And that's how you can use the calculator to achieve the same effect. Now, x squared plus 2. You might want to use the calculator for this one because it is a parabola. It's not a very complicated one, but we're going to do x squared plus 2. And then table. Now notice it says between 0 and 4. Now we're going to use open dots because it's less than. So I'm just going to go up here to 0. And it's 0, 2, 1, 3, 2, 6. So 0, 2, 1, 3, 2, 6. 0, 2, 1, 3, 2, 6. 3, 11, 4, 18. 3, 11, and 4. Let's put a mark up here. 18. Now, that means I only want that part of the parabola. We can look at what it looks like on the calculator with a sitting graph. But we only want the part. See where I'm putting this little mark here? It might be hard to see. But starting only at 0 and going up off the chart to 4. Somewhere up there. We only want that piece of the parabola. So therefore, I'm going to put an open dot here. It looks solid because I open dot there. That's 0, 2. And we have 1, 3. And I'm going to go up here, and like I said, it's going to be off the chart, and put an open dot there at 4. I might just make a note of it since it's off the chart. 418. So there's x squared plus 2 between 0 and 4. And then we're going to do y equals -6, which is a horizontal line that's going to be normally down here. But remember, we only want greater than or equal to 4. So that's the intersection down here, solid dot, and we're going greater than this way, which means we're going to erase this part right in here. So there is the graph of y equals -6 greater than or equal to x of 4. Now it says evaluate each of the following using the function above. So -4, g of -4. So if we plug in -4, which is right here, what do we end up with? Okay, so obviously it's not going to hit the parabola. It's not going to hit the horizontal line. It's only going to hit this first one, which means we plug in -4 to 2 times x minus 3, which is going to be -11, which mine kind of bent here, but it would go down here and it would hit a -11. We'll get off the chart. 1.5. So we look at 1.5. 1.5 is going to be right about there. Well, that means it's not going to hit the red sand line, 2x minus 3. It's not going to hit the blue, y equals -6. It's only going to hit the parabola. So we plug 1.5 in here. And we just take our calculator and we do 1.5 squared and then add 2 to it. So 1.5 squared is 2.25. We're going to add 2 to it and get 4.25, which, if you look at the graph, that makes sense. It's, somewhere right around there. But you can't tell from the graph, so that's why we use the graph to figure out which one to plug into. And then 5. Well, where's 5? 5 is right here. Now, it would normally hit that parabola if it went further, but since it stops at 4, it's not going to hit the parabola. It's not going to hit the red slanted line, 2x minus 3. It's only going to hit blue. Now, we should be able to figure out what the answer is, because what is y always going to be? -6. This right here is the point, 5, -6. And that's what it means. So you need the picture a lot of times to plug in to know which one to plug it into. Sometimes you can read right off the graph, like g of 5, but sometimes they're going to be off the graph, like the first one, or in between on the parabola, so we actually need to plug in and know which one to plug into from looking at the graph. Okay, so here we go. Absolute value of x plus 3 if x is less than or equal to -2. So we get my calculator, clear out that. Remember, we go to math, over to number, and there's the absolute value. And we put x plus 3. Remember, on the yellow calculators, we right arrow over to leave the bars. This one's a little bit different. And that's it. So we're going to use the table, but we only want numbers less than -2. Less than or equal to -2. So there we have it. So when we're graphing that, we're going to put only those points on our graph, going upwards. So that's going to be -2, +1, -3, 0, -4, 1, -5, 2, -6, 3. You can kind of see where it's going. -7, 4, -8, 5. So we only want that part of the graph. Our second one is x cubed minus 1. So we're going to use graph calculator again. So we're going to put in x caret third power minus 1. And we're only going to look for numbers greater than -2. put an open dot there. And remember when you're using the graph calculators in class, when you put an x cubed, you put that little caret up, you have to right arrow over to drop back down and put in the -1. Otherwise, you're going to put the -1 up with the 3, which would be effectively 3 minus 1, which is x squared. And we don't want that. We'll give you a parabola instead of our curvy thing. Now, we're going to put just these points in greater than 2, -2. So -2, it says -9. So we're going to put an open dot there, and then the rest we'll put solid dots. So -1, -2, 0, -1, 1, 0, 2, 7, and 3, 26 were already off the chart. So now we just do our snaky kind of shape. There we go. Starting at -2 and going up. So now we're going to evaluate. We're going to plug in -2. Well, obviously, -2 only hits in one place, right there. We can plug it in. -2 plus 3 is 1. Absolute value is 1. But notice that this one right here doesn't count because it's an open dot. So it does not actually hit on the cubic function. H of 0, well, from looking at the table, we know 0 leads to -1. Or you plug it in here. 0 cubed is 0 minus 1 is -1. H of 6, well, that's off the chart. We have two choices. We can plug in 6 here and do 6 times 6 times 6, which is 216, minus 1, which is 215. Or we can just use our handy calculator and go down to 6. There it is, 215. So it can really come in handy. Wrong button, sorry. Okay, now we're going the opposite direction. We're trying to write the equation given the information on the graph. So this is obviously the line y equals 6. Well, remember, this is already y equals. So we say y equals, I don't know why it was an x, y equals 6. So that's my first equation. But I don't want the entire line. I only want it for when x is greater than 2. And I put greater than because it's an open dot. My next one is, I need to look for points. Okay, my y-intercept is right here. It looks like a -3. So it's going to be y equals something x minus 3. And I'm going to count my slope. Up 1, 2, 3, 4, 1, 2. Or 1, 2, 1. Down 2, left 1. So that's a positive slope of 2 over 1 or 2x. So that's y equals 2x minus 3. I just use slope-intercept form. But only when fx is less than or equal to 2. Notice the solid dot right there. So I want to include x is 2. And that's it.